what types of scripts do we need? We've mentioned tag module scripts or classes, we've got services and data modules, but what all do we need to structure a video game? Well, ultimately, it's a bad idea to have scripts doing whatever they want. We've covered this kind of in detail and why it's a problem and the problems it causes. So we want to separate our logic from our data. The only way we can do this effectively without having a mess is to centralize our responsibilities. What does this mean? It means breaking our code into module scripts that do one thing, and they each have classes of what they are. So each module needs to be the master of its own world, its own stuff. It only handles what it's supposed to do. The inventory system should have no idea how much money a player has spent or how much they have. It shouldn't know how much XP they've got or what level they are. But what if someone wants to equip a piece of gear, which the inventory service would handle, and that gear requires them to be level 5? Well, the inventory service will ask the experience service, can I equip it? And maybe a function like this. And this function will return true if they are high enough level, or false if they aren't. In order to do this, we need to structure our module script into a set of patterns. Patterns meaning how the module behaves. Now, we've got these classes that I mentioned earlier, types of module scripts. We don't need to use all of them. But instead, think about your project and how you'd like to structure it to fit your gameplay needs. Well, what are the types of modules that we can use, the types of module classes? Let's go through these one by one. Think about the game you'd like to build and which of these would be useful with what you're trying to make. First, service modules. These are the backbone of the game. These are services. A service owns a major system and acts as the main controller for it. So for instance, things like currency service, inventory service, round service, vehicle service, combat service, matchmaking service, all of these systems would be services. A service should own its own data, control its system's logic, and expose functions for other code to use. For example, a service could look something like this. Currency service could have a function like add coins. The input is the player and the amount of coins you'd like to add, and then it would modify and return some sort of output. Likewise, we could do remove coins. So use services for game systems. A service is server-side, a controller is the same thing, but a controller is client-side. So it's the local script version of a service. Next, we have class modules. A class module defines the behavior of a specific kind of object. Use these when you want to create multiple instances of something with the same structure and behavior. For example, a car, a weapon, an NPC, a projectile, a quest, or a button prompt. Those would all be class modules. A class usually has a constructor, the .new function to build one, its own state, and its own functions. Take our RGB part, for instance. This is a class. So use classes for objects with their own state and behavior. Next, we have data modules. These store structured information. They usually don't run behavior. They define values, settings, configurations, or content. So for example, you'd use data modules for item stats, vehicle definitions, enemy stats, round settings, the map settings, or upgrade costs. Here's an example module that would contain the data for weapons. You'd have the name, the damage, the fire rate, and the price. So use data modules for static definitions. Next, we have utility modules. These are helper modules. They don't own a game system, they just provide reusable functions. For example, some functions you might need to reuse multiple times. Formatting numbers, building tables, a raycast helper, a string helper, a math helper, or an instance helper. Here's an example of a number utility module that you could use that would have some functions that you'd regularly find yourself reusing. So if you find yourself doing the same thing over and over again with the same function, you could turn it into a utility module that has reusable functions for other systems to use, and just to help automate some of the process of scripting. Next, we have controller modules. So remember, these are the same as services, but they're live on the client and they manage a piece of client behavior. So often you'll find them coordinating things like the UI, the input, camera, local VFX, or state display. Some examples would be a shop controller, a camera controller, a HUD controller, input controller, or a vehicle controller. So here would be an example shop controller. Use controllers for client-side orchestration. Next, we have component modules. Now, a component module is reusable behavior that can be attached to many things. This is useful when we have many different objects that share a feature. So for instance, damageable. Say for instance, we want lots of pieces to be able to damage something. We could create a component module that handles a part being able to cause damage. Then if we make something like an enemy or a spike trap, they both can reuse this same damageable component and to stick it on their own parts. So here would be a damageable component example. So use components for shared behaviors across different object types. Components are very generic pieces that do a very small thing that lots of objects or classes need to use. Then when you build a class, you can just comprise it of different components. Next, we have a manager or registry modules. These keep track of a collection of things. They don't always own the system, but they organize access to lots of instances. Some examples would be active vehicles, loaded NPCs, projectiles, player profiles, or registered interactables. Take this example here of a vehicle registry. This wouldn't control vehicles or build vehicles, but it would store vehicles that have been spawned into the workspace. So you'd have a class that would be the behavior for these vehicles. This registry would simply store those classes. That leads us into our next module that'll closely interact with this, a factory. So a factory creates the objects in a controlled way. Instead of building things manually all over your game, creation goes through one place. You'd have things like an enemy factory, a weapon factory, a vehicle factory, or an effect factory. Take a vehicle factory, for instance. It would access the car class, and then you'd call vehiclefactory.create and give it the model. It would build a car, and then it would store that car in the registry. And so factories are to be used when creation logic is repeated or needs rules. Next, we have shared interface or definition modules. These define shared constants, enums, keys, or contracts used across systems. So remote names, item types, round states, action names, or attribute keys. Think of it as your way to be able to make custom enum files. So enum.roundState, we could turn it into a module, like this one here. We've got waiting, starting, playing, ending. So that way, instead of having to manually type these strings and hope that we spell it correctly every time, they have the same definition, all these different scripts. They have the same definition here. And so use these to keep shared meanings consistent. So that way, different modules can all talk about the same thing. So what actually should be scripts and not just module scripts? Very little. Very little systems should actually be scripts. Usually, scripts just start systems. They don't contain any of the logic. So some good uses for script and script files would be a bootstrapper. What a bootstrapper is it initializes all of your services or controllers. So the bootstrapper, like this example here, turns the services on, and the services use everything else. They use the factories use the classes and the registries. The service also uses the shared definitions and the utility modules. And so really we build this hierarchy of the services on top, the bootstrappers turn them on, and the services use all the modules. The classes are near the bottom. They're used by registries and factories. The factories use the registries and the classes. And then the services use the factories. We're building this hierarchy of control to basically decouple our logic into manageable bite-sized pieces. So all we have to do is work on these manageable bite-sized pieces and then kind of have this trickle-down effect with how our code works. So here would be a good mental structure for a game. A healthy code base usually looks something like this. On the server side, we'll have services, server-only classes, managers, factories, and data access logic. Managers, also known as registries, and the data access logic is just our data modules that describe preset stored information. So you can see how the top 4 is ways that we can break up logic into bite-sized reusable pieces, and our 5th module just stores all the data, our 5th module type. That's where all the data goes, and we just plug that into the logic. Now the client, we would have our controllers, our UI classes, camera systems, input systems, and visual effect handlers. Most of these would be controllers. Really, most of our game logic is actually just going to be on the server. Now lastly, we have the shared folder, which will go in replicated storage. This is shared data modules, utility modules, shared class definitions, enums, constants, definitions, things like that. So that's kind of a good mental structure of how you want your project to look like when you're finished. And this is how we could feasibly create a game with 3 scripts, and that's it. 1 server script as a bootstrapper to turn our server-side services on, 1 local script to turn on all of our controllers, and 1 local script in replicated first just to handle our loading screen. The rest would just be modules on the server, modules on the client, and modules in a shared folder in replicated storage. So now let's go through these one by one, and I'll show you how to actually write and implement these types of modules in your game.